ladies and gentlemen, how are you doing this afternoon? Our topic today is triangle theorems. Hello, pen. There we go. And our objective is I am familiar with and know how to use a variety of theorems regarding triangles, such as the angle sum theorem, the exterior angle theorem. There's a third one also, which is called the triangle inequality theorem. Okay, if you could add that to your notes, that would be good. So, first triangle theorem that we need to talk about. Well, actually, before we get to theorems, we have to review a little bit about what different kinds of triangles are. There are two different ways you can classify triangles. So you can classify them by the length of their sides, or you could classify triangles by their angles, the size of their angles. So a scalene triangle is a triangle that has three sides that are not, three sides that are not the same. So three different length sides. Sorry about that announcement, if you heard it. With an isosceles triangle, it has two sides that are the same length. Two sides are the same, and the third one is different. And the third classification by side length is an equilateral triangle, and that's when all sides are the same. So after you classify a triangle by side, you can give it another name too and classify it by the angles. So an acute triangle has all angles less than 90 degrees, because an acute angle is less than 90 degrees. So as you can see here, they are all less than 90 degrees. 90 degrees is a right angle, like this one here. So an acute triangle has all angles that are less than 90. A right, oopsie, I hate it when I do that. Oh my gosh. Computer's being really fast today. A right triangle is a triangle that has one 90-degree angle. It's impossible for it to have any more than one 90-degree angle, because if you tried to make one angle that's 90 degrees and another angle that's 90 degrees, well, that doesn't make a triangle. It's the start of a square, okay? So keep that in mind. An obtuse triangle has one angle that is obtuse, and an obtuse angle is an angle greater than 90 degrees. Greater than 90 degrees. This is another triangle where you can't possibly have two obtuse angles. If you have one obtuse angle, the other ones have to be less than 90 degrees for it to make a triangle in the first place. Finally, an equiangular triangle has all angles the same, all the same size. And when you have an equiangular triangle, all the angles are going to be 60 degrees. And we know that because of a theorem we're going to be talking about in just a couple minutes. So you could have an isosceles right triangle, a triangle that has two side lengths the same and a right angle. You could have a lot of combinations of these different kinds of angles. Let's take a look then at some examples. If I have a triangle with angle measures of 30 degrees, 60 degrees, and 90 degrees, I want you guys to be able to find out what kind of triangle I would call that. I'm going to give you a couple seconds to figure it out, and then I'm going to tell you the answer. All right, my answer to number one is C. It is a right triangle, because a right triangle has a 90-degree angle, and this here has exactly one 90-degree angle. I'm going to show the rest of these and give you guys some time to see if you can match them up appropriately. Just put the letter next to each one, and then I'm going to show the answers and you can see how you did, okay? So pause the video in 5, 4, 3, 2, 1. This is what you should have gotten. Number 2 is an equilateral triangle, because all of my sides are the same length. Number 3 is equiangular, because all of my angles are the same size. Number 4 would be an isosceles triangle. Remember, an isosceles triangle has two sides that are the same length, like this one does. Number 5 is going to be scalene because the side lengths are all different. And number 6 is going to be letter D, which is obtuse, because I have one angle in here that is more than 90 degrees. All right, on to the theorems. Our first theorem is one that I think you're pretty familiar with. The sums of the interior angles of any triangle is 180 degrees. So if I have a 50-degree angle here, and I have a 60-degree angle here, and I don't know what this angle here is, I can figure that out by saying, okay, 50 degrees plus 60 plus some angle I don't know, perfect time to use a variable, has to equal 180 degrees. Then you would add those together, equals 180 degrees. Get x alone by subtracting 110. And there you have it, x equals 70 degrees. Now I know that might not be the way that you guys would solve this. You might say, okay, well I'm just going to do 180 minus 50 and then minus 60 and that'll give me my third angle. And while that's not technically wrong, we need to move towards an algebraic understanding. The algebra is important, so you need to be able to represent this triangle, this triangle algebraically and then solve it using algebraic methods, okay? Next we have, and you should have written all that down. If you didn't, go back and write it. Next we have the exterior angle theorem. The exterior angle of a triangle is equal to the sum of the two non-adjacent angles. Okay, let's break this down a little bit. Exterior angle is on the outside of the angle. So that is an exterior angle. Sum, we know that's addition. And now here, the two non-adjacent angles. All right, adjacent means next to. So we're looking for the two angles that are not next to the exterior one. So here is the angle that's right next to the exterior angle. We don't want to use that. We're going to use this and this because they are non-adjacent to my exterior angle. So to actually put this theorem into use, maybe you have x minus 40 is the measurement of this angle in here. And then this angle might be 3x, and this one could be 2x. All right? So to solve this, we know that the exterior angle, x minus 40, is equal to the sum, that's addition, of the two non-adjacent angles. So it equals 3x plus 2x. Now all I have to do is simplify this and solve. X minus 40 equals 5x. I'm going to go ahead, this is a very bad problem that I just made here. Bear with me though. I'm going to bring all my x's to one side, so I'll subtract x, giving me negative 40, because that subtraction sign becomes a negative, equals 4x, which then tells me that x is negative 10, which is why I made a very bad problem here. I just made it up on a whim, and I apologize. But that's how you would solve this kind of problem. Oh, what have I done to you guys? That's all right, though. We'll get it sorted out tomorrow if I hopelessly confused you. I could then find out the degree measurements of these angles by plugging negative 10 in for x, which you can see would give me negative angle measurements, but let's just pretend I didn't make that mistake. All right, moving on. Next, not quite time for the reflection yet, we have to talk about the triangle inequality theorem. And apparently I lost my slide at some point. But that's okay, I can type it. The triangle inequality theorem states the sum, I'll make that bigger, the sum of any two sides of a triangle must be greater than the third side. Ooh, weird. Hang on one second. All right, sorry about the weird pause there, guys. I was talking to somebody. Okay, so it then makes sense that if, oh my gosh, this computer's driving me crazy. If the sum of the two sides is less than or equal to, it cannot form a triangle. Oh my gosh, my computer is so slow. All right, so a quick example of this, because I know that I'm getting a little long on time. Let's say I have a triangle and the side lengths are 3, 7, and 8. Well, I can take any two sides here, 3 plus 7, that's greater than 8, so that's good. 3 plus 8 is 11, which is greater than 7, so that's good. And 8 plus 7 is 15, which is greater than 3, so that's good. But what if I went in here and changed that 8 to a 10? I would see then that I've got 3 and 7 here, and they add together to equal 10. Because they are not greater than the third side, this cannot possibly make a triangle. And either tomorrow in class or next week, we'll actually look at some examples where I give you some lengths and we can see why it's impossible to make a triangle with them. All right, finally, your reflection question. You are actually going to have to use the angle sum theorem and the exterior angle theorem in order to solve this. So that's your hint. You have to use two theorems to solve this problem. I want to know what the measure of this angle is. All right, look forward to seeing your responses.